It makes algebra come alive.
They all move through zero.
They all intersect through zero.
Yeah.
When you're doing transformations of functions, then lends itself very nicely to horizontal, vertical transformations, dilations. For transformations of quadratics, you can change A, B, and C the effect.
The kids get to see several lines in a textbook and maybe calculate the slope of several lines, but several lines isn't enough to be able to see all the different types of lines that you can get. Not just the ones with nice values like 1 and 3, but here these ones like 1.86. Of course, another thing that I asked them to do is to try and move that line so that the slope stays the same as they move the line. And it's very difficult to do that as you're moving points A and B. But soon a student will find that if they move the whole line, that slope value doesn't change. So they've created a whole family of lines for which the slope is exactly the same.
We use Sketchpad for functions and for lines, and we looked at y equals mx plus b and how that equation worked.
We use the Sketchpad algebra tiles to model equivalent expressions, distributive property, multiplying and factoring, multiplying binomials, factoring trinomials. You can create two different but equivalent expressions, and that they will stay equivalent even as the values of the variables in the expressions can change.
We've used it for a lot of the slope manipulation, the intercepts, discovering equations of lines, and we've used it for slopes of parallel and perpendicular lines.
There are a lot of different geometric relationships that kids can easily relate to and see, but not necessarily understand what a graph of that might look like. Okay, let's plot it, and having them talk about if it agreed with what they thought. It won't always, and they could talk about why, maybe why they were wrong. And I just think it's a really good way to introduce graphing, as you're really graphing for a purpose.
So the closer it is to zero, the flatter the line is on the graph.
But it won't go
But same line as what?
to it. Yeah. Well, it goes to one of them, but you can't have both of them there.
Oh, so just a line.
And then this has to try to be vertical.
In Algebra 1, my students benefit from Sketchpad a lot because we can work with functions in a dynamic way. We don't have to look at something like y equals 3x plus 4 and graph just that. They can work with m and b, slope and intercept if we want, or in other forms. It doesn't have to be even that. And they can change, literally, watch the graph change as they alter the slope. And they can watch it move instantaneously with the numeric change. And that's something that there's nothing else that's going to give us that option. Even a graphing calculator can only graph one at a time. It can't work with a changing parameter. And for the kids to see that, it's so obvious to them what everything is.
Now, back out where you were there, where you had it was about 0.34, something like that. So I know that you're comfortable with that fraction. What would that 0.34 fraction be? Approximately. So you had about a 3-to-1 ratio. Yeah.
We do an activity looking at inequalities on a number line where you can drag an x value on the number line, but you're paying attention to what's happening to an expression in terms of x, like say 2x minus 1. And you want to drag x so that 2x minus 1 is, say, always greater than 5. And you're watching that little tick mark sliding to the right of 5 while your x is shading in all the values that make that true. So it's a kind of dynamic way, and it's fun for the kids to see a solution set to an inequality.
When they have to solve an equation, they'll be able to see, using the balance, that it's either right or wrong. And I think that's probably, they're going to have that instant feedback. Sketchpad is going to give that to them. I think that it's going to enable them to be more engaged because they're going to be working on the computer. It's almost like playing.
Other way.
No.
Other way. X, Y. 3, 5, right there.
Oh, do that again.
You negative 1 over, yeah, that one's right.
A little bit. No, you just have to adjust a little bit. There. Oh, I just had it. There. Perfect. Yay.
This is the commutative principle, the fact that A and B produce the same behavior. When I move A, you can see that I have the same behavior that I had with addition. But if I grab B now and drag it, I have a completely different behavior.
We don't have to remind them what a positive slope is. They can see it, and if they forget, they can type in a negative value and see how it changes. Because of that, I gain time, and as a result, I know I'm gaining meaning. I know that kids who often would shut down in the classroom won't shut down in the lab.
In the lab, they think nothing of leaning over and asking the person next to them, so how do you do that? Or how do you get to that point? Or why is yours spinning and mine isn't?
Why? I already have 3 letters. Yeah. How? Delay that. Click on the dot, and then click on this line, and then go construct perpendicular.
They would become the experts. They would know much more about Sketchpad than I ever dreamed of knowing, because they'd say, what about this? Well, try it. Let's go and check out what you're thinking of.
The y-intercept, or B, is 4, so we brought it up here so it intercepts the y-axis at 4, and it's negative 1.5, and since it's a negative number, it'll decrease and go down like that.
When you can plot 2 values as x, y, you can see the function that you can see how 2 different parameters are related, how area is related to the side of the square. And you can have kids, developing conjectures about what, if the slope of something should be steep, if it should be shallow, if it should change. And I think that's, in some ways, the essence of algebra.